Hello everyone, I would like to share our latest work in SIGCHI 2024, Understanding the Needs of Novice Developers in Creating Self-Powered IoT. I am Chengshuo from Tian University, China. The work was also collaborated with researchers from Keio University. The proposed energy harvesting technology brings a very promising solution to the problem of powering hundreds of millions of IoT sensor nodes. The distributive IoT nodes could collect the various ambient energy for the related energy harvesters, converting the ambient energy into electricity. It makes an eco-friendly, self-sustaining, and deployment-flexible system. However, we may lose this prophecy because of energy harvesting-based systems' complicated and laborious development. Unlike a common stable battery or power source-based supply, the energy harvesting system normally suffers from serious environmental fluctuations. It requires the whole system to have a careful design of hardware and software to guarantee a stable operation. We therefore raise the question of what novice developers need to create an energy harvesting-based IoT node. We target our focus on novice developers because it would be helpful to avoid expert blindness, which is when experienced developers are unable to perceive the difficulties encountered by novices when approaching a new domain. Also, novice developers are open to trying new technologies and approaches and are likely to adopt them for future practices in their development. Thus, in this paper, we studied the novice developers' needs in a mentored physical prototyping study and summarized the findings as design implications for future tools in developing self-powered IoT systems. Energy harvesting could be utilized to create an interactive system. Via sensing the variation of harvested energy in the environment, the user's motion and intention can be inferred to enable the functions of computing systems. To increase the reliability of energy harvesting systems, technology pillars have been proposed, both in hardware and software aspects. For example, commercial off-the-shelf ICs for energy harvesting and research on an operating system dedicated to energy harvesting-based systems. In addition, in recent years, the work for integration tools and platforms has emerged into energy harvesting, aiming to build a more convenient and fast development process, such as the embedded electronics toolkit and the design software. To better understand developers' different knowledge levels, we first recall the existing platforms and tools. We then identified three main development aspects of energy harvesting development: design, hardware, and software. We developed an evaluation board to help the novice developers and the expert to better test the various modules of the system during the study. For the main study, novice developers needed to complete two IoT development tasks. The first one is an automatic outdoor lighting system similar to solar-sensitive streetlights. The second task is to build an interior door or window monitoring system. It can be deployed on a door or window to alert users when an unexpected person opens it and enters the indoor environment. We recruited a total of 8 novice developers who were novice electronic developers. They are undergraduate and junior PhD students majoring in engineering disciplines from an institution in North America. The duration of each task was 2 hours. Thus, each novice participant performed a 2-day, 4-hour mentored physical prototyping study with the expert. We provided 5 types of energy harvesters and other basic electronic components. We also supported novice developers with example C code. Our work centered on a mentored physical prototyping study modeled after a pair programming study. In the study, the novice developer implemented the system development as the driver. The expert with expertise in energy harvesting system building worked as the navigator to provide the necessary assistance to the novice developer's design. All studies were recorded and transcribed later for analysis. Here is an example of the process for novice developers and experts when conducting experiments. We analyzed the novice developer's main steps when creating the energy harvesting IoT for these two tasks. We also recorded the expert's necessary help for analysis. Through three main analyses, including the observation of the study, interview with novice developers, and interview with experts, we concluded two main aspects: the gaps between concept and practice and the need for assistive features. Firstly, the novice developers were all aware that using capacitors could help reduce the system's instability. However, when the capacitor was provided to the developers, the participants would raise at least one of the following questions. For example, the question from the participant: how does this capacitor work? How does the capacitor work in the circuit? Secondly, the novice developers had little idea of how to convert the power concept knowledge into practice. They usually did not have the practical skills to measure power. The novice developers recalled the formula for power calculation, but it was difficult for them to determine which circuit configuration to use to measure the voltage and current. Thirdly, the question that was frequently raised was how to read the sensor's digital signal during development. The participants understood the basic concepts of analog to digital conversion and sampling, but often needed to look into setting the sampling frequency to enable the system to operate in intermittent mode with the duty cycle. For these three gaps, novice developers need to bridge them with relevant hands-on experience in basic electronics, which could help them acquire the skills necessary for energy harvesting systems faster. For the gap specific to energy harvesting, they all used energy harvesters with expectations and conventions inherited from their previous experience with batteries. They expected them to be as easy as using battery power and that their power and output would be stable. Almost all developers indicated they had a more practical understanding of energy harvesting technology. For example, I didn't expect the solar cell to produce such different outputs for different lighting conditions. We also consulted the assistive features, including the capacitor calculation, to help with a quick and suitable selection. The optimization strategy could assist the novice developer in better conducting the power design. Finally, the simulation tool would help the novice developer understand the power information of the energy harvester and reduce the complexity of development. Here is the summary of our study's findings. Therefore, the related implications for designing a novice developer targeted toolkit could be concluded. We presented 6 main topics, including educational efforts, required functionalities, logging strategy, simulation, physical form, and areas to avoid. In this paper, we first recall the existing platforms and tools for energy harvesting and categorize the different developers' knowledge. We then present a mentored physical prototyping study to figure out the needs for novice developers when creating the energy harvesting IoT system. The findings are concluded with several design implications for future toolkit design. You can refer to our paper for a detailed reading. Thank you very much for your listening.